Okay, back again. This time we're going to be talking about absolute extrema on infinite intervals, so between negative infinity and infinity. So we're going to talk a little bit, there's quite a bit of writing as you can see, so try to, again, pause as you need to and follow along. What do we know in general about the graphs of polynomial functions? So we're going to start talking specifically about polynomial functions and then we'll look at other ones later. Well, we know if the degree of the function is even and the leading coefficient is positive, that this function will rise to the left and the right. So it'll look something like this. Again, we don't care what's happening in the middle. We're just looking at what's happening on the ends there. Anything could happen in the middle. If the degree is even and the leading coefficient is negative, it will fall to the left and to the right. So again, looking something like this. If the degree is odd and the leading coefficient is positive, it will fall left and rise right. So that's this one. And if it is degree is odd, leading coefficient is negative, it will rise left and fall right, which looks like this. Okay. So which cases would give us absolute extrema? Well, again, remember we're looking all the way from negative infinity to positive infinity. So if we look at this first case, we can see that on the left and the right they're going to infinity. But we're going to have somewhere down in here in the middle a case where we will have an absolute minimum. In this next one we have, again, left and right, they're both going to negative infinity. But what's going on in the middle is any number of things, but at some point in there it's going to get to its highest point before then it falls back down. But when we look at the last two situations where we have degrees that are odd, either positive or negative leading coefficients, we can see that we cannot find the absolute maximum or absolute minimum because this was going to negative infinity while that goes to positive infinity and vice versa on the other one. So we only have really two situations for polynomial functions where we're going to find absolute maxima and minima. Alright, so if we talk about in general, not just about polynomial functions, but about functions in general. Okay, there's four scenarios here. Here they are, 1, 2, 3, 4. So again, you're going to need to probably pause so you can write these down. If the limit as we approach positive and negative infinity of some function is the same, okay, in this case if it's positive infinity, then we're going to have an absolute minimum. Okay, that would be sort of like the even positive polynomial. If the limit as we approach positive or negative infinity is both negative infinity, then we're going to have an absolute maximum. Again, sort of like the second scenario here of polynomials, that graph. However, in both of these situations, what we're going to see is if we take the limit of the function as x approaches positive infinity and we take the limit as x approaches negative infinity, and they go to opposite infinities. Okay, so if they go to, one goes to positive and one goes to negative infinity, then we will have a situation where the function has no absolute extrema. Okay, so we're going to look at an example of finding absolute maxima and minima. Set my marker down. Alright, so we're going to determine the absolute extrema if possible. And in this case, we're going to start off by looking at a polynomial function. 3x to the fourth plus 4x cubed. So we need to first determine if we would have absolute extrema. In this case, we can tell that we will because we have a degree that is even. We have a leading coefficient that's positive. So yes, we will have an absolute minimum. Okay, and we know that this minimum is going to occur at a turning point. Okay. Now, there might be multiple turning points, but we're going to have to determine which turning point gives us the absolute minimum. In order to find that turning point, again, we have to find the derivative. So we will do that quickly. This is 12x cubed plus 12x squared. And I might even go so far as to factor that out to leave me with 12x squared times x plus 1. Because I know in order to find those turning points where they are, we have to find out where the tangent line to this function is horizontal. So we want to know where the slope is 0. So we're going to set that derivative equal to 0, or 12x squared equals 0, x plus 1 equals 0. So in this case, we get x equals 0, x equals negative 1. So we actually have a couple of turning points in this particular function, and we need to find out which one gives us the absolute minimum. To do that, again, similar to what we did earlier, we're going to go back to the function itself, and we're going to evaluate at both of these values and find out what happens. Well, when x is 0, 3 times 0 to the 4th plus 4 times 0 to the 3rd is 0. But 3 times negative 1 to the 4th plus 4 times negative 1 to the 3rd is actually negative 1. Okay? And since this is the smallest value and we know that we're looking for an absolute minimum, we will say f of x has an absolute minimum of negative 1 at x equals negative 1. So we just found an absolute extrema on an open or a infinite interval. Okay. All right, keeping in mind that same thing we just talked about, let's look at another example where we're not looking at a polynomial function, but this time let's look at a rational function. Oops, I forgot to say this was an example. Determine whether f of x equals 1 over x squared minus x has any absolute extrema on the interval. This time we're going to look at an open interval 0 to 1. Looking at infinite intervals is similar because an infinite interval is an open interval. So now we're looking at a smaller open interval from 0 to 1. The process is going to be similar. But in this case, in order for us to determine that, we've got to look at some limits. So we're going to look at the limit as x approaches positive infinity of 1 over x squared minus x. Oh, no, I'm sorry, we're not going to look at infinity because we don't want to know anything about that interval on infinity. We want to know the interval from 0 to 1. So again, if I think about a number line, I have 0 and I have 1, and I'm wanting to find out what's happening in the middle here. I'm actually wanting to find out what's the limit as x approaches 0 from the right. Okay, as x approaches 0 from the right. And again, sometimes it's helpful to factor out that bottom. So we have x times x minus 1. And we're going to find out that this is negative infinity. And what we're going to find out when we look at the other limit, the other end of the interval, which was at 1. So now we're going to be approaching 1 from the right-hand side. And we're going to also end up with negative infinity. So if you look back at what we found earlier, we said that if the limits, as they approach each end of the interval, go to the same thing, in this case, negative infinity. We will, in fact, so we will have an absolute, in this case, maximum. Okay? How can we find the actual absolute maximum? Well, the same thing we've been doing for several days. But I'm looking at the clock, and I'm at 10.5 minutes, and I'm going to have to stop and restart the video on the next. So sorry, we'll finish in a minute. Hang on.